1.48 Trig Functions Basics. We are going to split this into two videos because otherwise it's just unwieldy long. So today will be some basics on trig and sine and cosine, tangent, secant, cotangent. And then the next video, feel free to watch it right after this one, will be some of the more complicated graphing, trig identities, and the law of cosines. So the first thing we have to know in calculus is that we don't use degrees. Okay. We use radians. I'm sure you're familiar with it, but it is a real number way to measure angles. Okay. Degrees repeat. Radians can go on forever in either direction. So just be aware that we have radians because calculus deals with the real numbers. And we need something to represent that in calculus. Okay. Remember, we have a circle that might be 90 degrees, is also pi over 2 radians. Okay. This 180 degrees, pi radians. Okay. Whole circle is 2 pi radians. Now how do we generate that? Okay. This is the circumference of circle with radius 1 unit. That is where we get radians from. Okay. Beware, we can revolve once and get 2 pi, revolve twice, 4 pi, 3 times 6 pi. Conversely, you can start here and go backwards. Okay. And we can do, this is 90 degrees, but it is negative 2 pi, or sorry, negative pi over 2 radians. If we're going backwards, we're in negative, so it gives you a direction indicator as well. If you want to do successive angle measures, okay, you're going to see something like this. Pi over 2 plus 2 pi k radians, where k is an integer. Remember that an integer is a set of numbers that do this. Okay. So if this is true, we have pi over 2 plus, then here we have pi over 2 plus 2 pi times 1 plus pi over 2 plus 2 pi times 2 and on. So this is pi over 2. Sorry, this is going to be commas. Then we have a so this is a sequence. Pi over 2 plus 2 pi is 5 pi over 2. Then we're going to have 9 pi over 2 etc. So basically every time it goes around at 2 pi, then we have 5 pi over 2, another revolution, 9 pi over 2. And it will keep going in that same pattern. Okay. Formulas. To convert. If you want to go from degrees to radians, you put degrees in times pi divided by 180, get your radians out. If you want to look at an example, I'm not going to take the time to, but it's example 1 in your book. Okay. We're working in Rogowski's AP Calculus. Okay. There are some popular angles that you should know. Okay, just have them memorized. In the bottom, page 25 in your book. It will make your life a lot easier. Okay, 0 radians is 0 degrees. 30 degrees is pi over 6. 45, pi over 4. 60 is pi over 3. 90 pi over 2. You can see the succession in numbers makes a little pattern. Now on a unit circle, okay. Yeah, we don't need to show you that, but just have these memorized. Okay, that's a good idea. Okay, we have 6 trig functions we work with. Sine is the first one. Okay, you've probably worked more with right triangles than anything else. Remember that that is adjacent to this angle. This is opposite because we're coming across, and this is a hypotenuse. Okay, so the sine of, we're actually going to introduce you to a Greek letter, theta. So sine of theta is adjacent over hypotenuse. Remember cosine theta, sorry, sine is opposite over hypotenuse. Butcher. Okay, B over C. Cosine is A over C. Tangent is opposite over adjacent. Many people like to SOHCAHTOA. Some people like to just say SOHCAHTOA. Some like to say some old hippie caught another hippie tripping on acid. Okay, you can thank your principal for that. But those are the 3 basics, and then we can have secant, which is 1 over cosine, okay, which just flips it. It's cosecant, 1 over sine, which flips it. And cotangent, 1 over tan, which flips it. You're going to have to use this in your calculators because there's no function for these, so just use 1 over sine, 1 over cosine. Be aware, secant and cosine go together. Your tendency might be to go cosine and cosecant, but they don't. That's sine. So sine
goes with cosecant, cosine with secant. Okay. Something you ought to know. Cosine of negative theta. So if you're going backwards, so like sine of negative 90 is the negative sine of 90. So sine, let's do it in radians, negative pi over 4 equals the negative of sine of pi over 4. Okay. Cosine of negative pi over 3 is the same as the cosine of pi over 3. So just two small properties to look out for on that end. On your calculator, just want you to make aware of a couple things. So instead of, if you go to mode, so I press the mode key, we're going to make sure we're in radians here. Okay, radians versus degrees. I want to evaluate this, negative sine pi divided by 4, and it should be, we're going to memorize some of these values. 3 decimal places is enough for AP. Okay. This is actually a fraction. I believe it's root 3 over 2, root 2 over 2. And you'll be memorizing those, trust me. Cosine of pi over 3 is 1/2. Okay, you'll be memorizing that as well. There's a table on page 27. Take a look. We'll want to have those in our brains. Okay. Decimals, bad. Fractions, good. Back to the unit circle. You're going to learn this is important. Surely you already have from Trig, but if you have a unit circle, radius 1, you can form a right triangle, angle theta. This is your x and y. So you have an x value and a y value out here on the circle. This is the x, y. It's just a coordinate. The really neat thing is that this also corresponds to cosine theta, sine theta. And the x value is cosine theta, the y value is sine theta. Because the radius is 1, the hypotenuse doesn't count. Dividing by 1, because this is adjacent over hypotenuse. So x over 1 is x. Okay. What I would like to see, continuing on this table from page 27, okay, if you have an angle that is pi over 6 radians, the points for that are root 3 over 2 and 1/2. So this is cosine pi over 6. This is sine pi over 6. Okay, you can punch that in your calculator if you need to, but you're not always going to have it available. Similarly, let's call this pi over 4 radians, which is 45 degrees. Root 2 over 2, root 2 over 2. Okay, in your book on page 26, memorize those and that table on page 27. All right? They're very important. You'll find it very easy to do 0 degrees, which is 1, 0, and 90, or pi over 2, which is 0, 1. The 3 you have to memorize are 30, 45, and 60. Okay. They correspond to special right triangles, 30, 60, 90, and 45, 45, 90, oddly enough. Okay. Last thing for this video, basic graphs. Okay, I'm going to go over sine and cosine. I'm going to go through all of them actually, and then tomorrow the next video will be shifting them, etc. Okay, so I'll just go from zero to 2 pi. So sine is bounded by -1 to 1. Crosses the x-axis here. Goes like so. Okay, good idea to memorize those as well. And if you want to go backwards, it continues on so, like so, etc. Okay. Cosine theta. I'm actually going to put it in green here, just to make it easier. Starts at 1, down, so it makes a smooth curve. And if you want to continue it, you can. Okay, so these continue on if we want, but I'm just doing it on the interval 0 to 2 pi. Remember that interval notation. Okay. Let's look at tangent. These are where it gets a little bit funky. Kind of put your brain in your head. Tangent is undefined in certain spots. Negative pi over 2, pi over 2, 3 pi over 2, and so on, so that the graph looks something like this. Notice that 0, pi, if you did it again, it would be 2 pi, or where it crosses, so tangent of pi is 0. Okay. I'm going to do cotangent here as well, in green. Right. And it's literally what you would think of it. You know what, let's change that. I'm going to do secant here. Okay, secant has the same undefined spots as tangent, and it looks like this. this spot is 1. Okay, and then negative 1 is, and it continues this pattern. Okay, up and down, up and down, up and down. Now we can look at cotangent. It has different spots where it's undefined. So negative pi, 0, pi, etc. And it looks like this. Okay. That's cotangent. And then cosecant is the same issue. As secant. Notice cosecant and secant have no zeros. If you can tell me why, I'll give you a bonus point in class. Okay. That's all for today. I'm going to put all of the homework. Get my drive up here. Should I have this ready? Feel free to just do the first part of it. Okay, so the first part so it's 1.4a is 1 through 4, 6 through 9, 16, 20, and then you're going to do spiraling 1.1, 38 and 47, 1.2, 17, 41, and 1.3, 34. The next video I'll show you the rest of it, but here's the work if you want to start. You're going to start to see some of these spiraling problems get harder. Okay. But this is B. So this will be the next video. This is on this video. If you have any questions, bring them to class. Toodles.